Hello everyone, I'm Gemini T, AI consultant, and today I will show you Session Re-Rank Plus, a session-aware AI assistant powered by Gemma 4 that helps 8.5 million smallholder farmers in Karnataka find government services, whether checking land records or subsidies. Farmers shouldn't navigate 15 plus portals for answers. Let's begin. Every morning, 8.5 million farmers in Karnataka ask, what should I do today? Should I irrigate? Which scheme can I apply for? The answer exists, but they are scattered across 15 plus government portals, each English first, each with no memory. Every query starts from zero. Information exists, assist doesn't. Farmers need an assistant that remembers context and learns from every interaction. Session Rerank Plus is that assistant. Ask in Kannada, Hindi, or English. Get unified contextual guidance. The system learns from every session and it connects to 15 live Karnataka government APIs. It doesn't just answer, it adapts. Here is how it works. A farmer enters a query in Kannada or English plus that profile, crop, district, season. Gemma Force embedding Gemma 300M encoder converts that text into a 768 dimensional vector capturing semantic meaning. Our co-activation cache tracks which APIs farmers use together, like weather then market prices, strengthening those connections over time. Session-aware scoring combines three signals: 50% embedding similarity, 30% profile match, 20% cache bonus. The result: ranked APIs with plain language explanation. When a farmer selects an API, we update the cache, closing the learning loop, all in under 300 milliseconds. We validate Session Re-Rank Plus using two complementary datasets. Layer 1 Toolbench 43,000 APIs, 7,600 queries for statistical rigor. Layer 2 Karnataka Catalog 15 live government APIs for real-world impact. Toolbench proves the algorithm works. Kannada language support proves it helps farmers. Same embedding space, same pipeline, consistent proof. Let's start with data layer. Toolbench has three components: an API corpus with structured metadata, a query set with human annotated ground truth, and session trajectories that seed our co-activation cache. We evaluate across 6 splits, testing robustness. The evaluation splits range from general domain natural language queries to a highly complex long-tail queries reflecting real farmer needs. This full spectrum validation ensures the algorithm performs well everywhere. This is where theory becomes practice. The Karnataka catalog structures 15 real APIs: weather, land, advisory, pest, soil, market, schemes, dairy, with bilingual metadata. Each API's doc property concatenates English and Kannada for Gemma embedding. Profile filters enable personalized ranking. This isn't synthetic data. Every API is live and used by farmers today. The key that makes both datasets work together: Gemma 4 embedding is the linguistic bridge. It encodes Kannada queries like Nanna Ragi Belage Yojane and English queries like schemes for ragi crop into the same vector spaces. No translation, no fine tuning. Pre-trained on scientific corpora, it understands terms like Kharif, Rabi, PM Kisan at 300 million parameters and approximately less than a 50 millisecond latency. It's fast enough for rural networks. With a graceful fallback to mini LM, reliability is built in. Session trajectories map a user's journey between APIs during a single conversation. If a farmer checks the weather and then irrigation, the system learns and proactively ranks irrigation higher next time, enhancing session continuity. This brings us to how validation meets deployment. Toolbench validates the algorithm. Karnataka API catalog applies it. Gemma embeddings provide the semantic foundation. Co-activation cache adds session awareness. Let's trace a single query through this entire system. A farmer asks, should I irrigate today? Gemma encodes it to a 768 dimension vector. We compute cosine similarity against pre-computed API vectors in under 2 milliseconds. Session-aware scoring ranks results. We return top 5 APIs with explanations. The entire pipeline runs in under 100 milliseconds, fast enough for rural use. Before we look at results, let's make sure what we are measuring. What do we evaluate? We evaluate how well we ran the right API. It's measured by top 1 hit, top 5 hit, NDCG at 5. Why are we measuring? To prove real help, build trust, guide improvements. When are we measuring? During development, pre-deployment, post-launch. Where are we measuring? Tool bench for research, Karnataka API catalog for real world. How are we measuring? 7 steps. Load queries, generate rankings, compare to truth, compute metrics, aggregate, test significance, publish. Let's look at the actual results from our dashboard. System setup 3211 tools, embedding Gemma 300M device GPU, session multi-turns. Key results G1 instruction split, that is from general domain. Session re-rank achieves for top 1 64% and NDCG at 5 of 65%. This is 12 to 13% improvements over baseline. Statistical significance P equals 9.7 times 10 power minus 7, that is 99.999% confidence. Across all 6 splits, mean NDCG at 5. The improvement is 14.7%, biggest win 20.7% for a domain-specific instruction like PM Kisan eligibility, exactly what the farmers ask. But what do these numbers mean? A farmer in Tumkuru asked about schemes for ragi with baseline 57.5% succeed on first try. With session re-rank plus 64.5% succeed, that is 7% more. Aggregate impact 555,000 more farmers succeed instantly across Karnataka. Time saved 250,000 hours annually, equivalent to 250 full-time agricultural officers. This is our Hugging Space live dashboard. A farmer asked in English about their ragi crops, yellow leaves and dry patches. The system in under 100 milliseconds recommends solutions from government portal, KSDA Pest and Disease Alert. The retrieval details show that the system uses crop, district and season context for ranking. It leverages APIs like KSDA Pest and Disease Alert, Raita Mitra Crop Advisory, prioritizing results based on farmers. Please scan and visit the live dashboard where you can see all the results and metrics we got in our experiments, interactive charts, p-value and matrices. You can also see that the 13.6% improvement over the baseline. This screenshot summarizes our contributions. First, the co-activation cache algorithm with delta row update rule. Second, zero-shot bilingual retrieval via Gemma. Third, two-layer evaluation, bridging research and practice. Fourth, open source release with Apache 2.0 licensing. Each contribution has proof. 14.7% NTCG. Equal performance in Kannada and English. Shared pipeline. 100% reproducibility. And this isn't just for agriculture. Session Re-Rank Plus extends beyond agriculture in education, helping 260 million students navigate learning platforms in healthcare, guiding 500 million patients to the right service, same pattern, fragmented services, session-aware needs, multilingual users, same metrics, top 1, top 5, NTCG at 5. Expected impact 12% at top 1 gains across all domains. For extension developers, we provide helpful links to the core code, a reference implementation for agricultural services, the live metrics dashboard, and official Gemma for multilingual documentation. None of this would be possible without the Gemma team's support. Thank you, Gemma team. Embedding Gamma 300M made inclusive AI possible for 8.5 million farmers, native Kannada support, agricultural context, zero shot cross-lingual, Apache 2.0 license. Because of your work, it's now possible extending to education, healthcare, legal aid, etc. Thank you for your time and attention. Session Re-Rank Plus proves session-aware retrieval can turn fragmented service into intelligent, inclusive assistant. This is Apache 2.0 license, reproducible, ready to scale.